All right, here we go. This is part 2. We're just going to do a couple examples and we'll be done, so this should be kind of short. All right. Let's go to the pen tool. All right, here's the example. All right, example. I'll call it example 1. And here it is. It's log base x of 8/27 equals 3. Now this time, they're not asking you to just change it from logarithmic form to exponential form, okay? They're actually going to ask you to solve for x. So this problem says to solve, but they don't ask you to change it from logarithmic form to exponential, but that's what we need to do, all right? Because right now we don't know how to do any math with logarithmic form. Yeah, we can change it to logarithmic form, but we don't know how to do any math with it. You will a little bit later, okay? We're going to learn some rules. That would be the next lesson tomorrow probably. But for right now, we don't really know how to do any math with this. All we know how to do is change it from logarithmic form to exponential form. But remember in section 5.2, we did learn how to solve for those. Remember when you had the base the same, the exponents equal to each other and all that kind of good stuff. That's what we're going to try to eventually do. So it looks kind of ugly right now, but let's do it. Let's change this from exponential form, from logarithmic form to exponential form. Everybody okay with that? So let's try it. I always like to start with the base first. What is the base here? Andrew, what is the base to this whole thing right here? Is it that small? You can't see it? The base is 3? It's just the x. It's not the log, it's just the x. Okay, that's your base right there. So you write base to the power. Which one of these is the power? It's the 3. So you go x to the third equals the number. Which one is the number? 8/27. Good. So what we did is we changed it, okay, from exponential, I keep saying that, from logarithmic to exponential. Now this looks kind of familiar, doesn't it, as far as solving for x? You've done this kind of thing before. Really, you could do this a couple ways. You could just take the cube root of it. I'll tell you what, let's do it the way that we learned. Remember we try to get the bases to be the same or the exponents to be the same? Which one? Do you think I can get the bases to be the same here? I don't think so, because look, this is base x. There's no way I can get this to be a base x, but I could get the exponents to be the same. So Emily, what do you think? If this is x to the third, can I make either one of these or both of them to the third? Yeah, it's 2, right, it's 2 to the third and it's 3 to the third, exactly. Do you see that? You should recognize those numbers and look at it and say, oh yeah, I can write this as a cubed. So watch what I'm going to do. I'm going to write x cubed equals 2/3, just like Emily said, to the third. Because 2 cubed is 8. You guys watching? Okay, up here. So 2 cubed is 8 and 3 cubed is 27. All right, so it's the same thing. Now watch what we do. When the exponents are the same, what do you do with the bases? Make them the same. Very good. Just set them equal to each other. And x is equal to 2/3, just like that. It's pretty easy, isn't it? Or you could have done this. You could have just taken the cube root of both sides. What's the cube root of 8? 2. Cube root of 27 is 3. You could have done that as well. I just wanted to go with this just to kind of remind us what we did before. We good with that? All right. Again, if you're not sure about it, if we go a little fast, you can always go on YouTube, all right? Take advantage of that. I've already had emails from some parents already that their kid didn't understand it during class. They went back home and they looked at it again, even a couple times, and they finally were able to understand it. One girl was absent the last 2 days, and she got on YouTube even before she came back this weekend. Her mom wrote me and said that she watched the lesson on YouTube, actually did the homework, and she was gone for 2 days. So she was absent for 2 days, came right back into the class, and just jumped right into where we left off. So it's a great, really is a good resource. So take advantage of it, okay? What's that, Emily? It's awesome. It is. It's good. It's a really good resource. I mean, it wasn't my idea. Other teachers have done it. I've gone on some websites. There's this teacher called, it's not YouTube, it's like TeacherTube or something like that. It's TeacherTube, and you can go on there. Yeah, I think it might be .com or .org, I'm not really sure. But if you go to TeacherTube, and then it's got searches on there. You can search what topics and stuff. And there's actually teachers that are doing what I'm doing right now. That's where I got the idea, that they actually teach in their class with this and put it up on that TeacherTube. I just put it on YouTube. You think? That'd be kind of cool. Then I could say I started it. Even though it wasn't my original idea. It'd be really cool if it was my original idea, but we'll just tell everybody, yeah, he came up with that all. Actually, I don't care. All right, here we go. Let's do this. This will be the last one, we'll be done. Again, it's in logarithmic form, so what do we want to do? We want to change it to exponential form. It's kind of the same deal, kind of. Look, take the base to the power, right? After you get used to this, you see this all the time. What's the base? 4 to the power, which is 5 halves. So we write 4 to the 5 halves, and that equals the number. What's the number? That's x. And look, you got x by itself. Now you just have to figure out what 4 to the 5 halves is. I'll tell you what, let's come over here. Write it a little bit bigger. We've talked about this before, but again, let's go over it again. 4 to the 5 halves. You could write it a couple ways. This is how I would approach this problem. I would write this as 4. Look at the base. The base is 2 right here. Or the denominator, not the base. The denominator is 2. So I like to write this 4 to the 1 over the denominator first. Again, they've rigged this, haven't they? Because 4 to the 1 half, okay, is the square root of 4, and you can take the square root of 4. They wouldn't put anything in there that you couldn't take the square root of, okay? They made it work out real nice. So this is 4 to the 1 half to the 5th power. Who's singing opera? Is that Shelby singing opera? 4 to the 1 half to the 5th. So what is 4 to the 1 half? We just said it. 4 to the 1 half is the same thing as the square root of 4. What's the square root of 4? It's 2. So it's 2 to the 5th. Do you know what 2 to the 5th is in your head at this point? You know 2 cubed in your head. What's 2 cubed? Without even thinking about it, what's 2 cubed? 2 cubed is 8. 2 to the 4th would be?
32.
Come on. 2 cubed is 8. That means 2 times 2 times 2 is 8. 2 to the 4th is just 2 times 8, right? Which is 16. And then 2 to the 5th is 2 times that, which is 32. Okay? And you don't need a calculator for that, do you? And actually, what'd you do? 4 to the what?
For 5 seconds.
You just did that in your head? 4 to the 5 over 2 in your head?
My calculator.
Oh, I see what you're saying. Oh, so you did use your calculator. I was thinking you did this without your calculator. Yeah, but let's not do it that way. Let's figure out how to do it like this, okay? Come on. This is why we learn this stuff. All right, so that's 32, and that's your answer. Now, that makes no sense to you, does it? Log base 4 of 32 equals 5 halves. I mean, to you, that doesn't mean anything. Well, because we haven't really learned anything with logarithms yet. The only thing we've learned today with logarithms is just changing it from logarithmic form to exponential form. And then we did all the stuff that we've always done with exponential form. Does that make sense? We will eventually, next lesson, learn some rules for logarithms so we can actually do this kind of stuff on our calculator. All right? For instance, what was that other one? I forget. I've erased it. But remember we had like log base 2 of, I don't know, 8 equals x. You could take something like this. Watch this. You could take this, change it into exponential form, but you could also do this on a calculator. You want to see? It'll be a sneak preview, okay? What is it, log base 2? Watch.
It was log base 2 with 8.
Yeah. Is that one we did earlier? Yeah. Okay. So watch. This is how you do it on your calculator, but we officially haven't got there. So this is sneak preview, so don't tell anybody, okay? This is free of charge. We won't charge your tuition fee for this one. So watch. If I'm going to go, there's actually a log button, I think. There it is. Okay. I'm not used to using this calculator on my little scientific calculator. The log button's up top here, so that's where I was looking. But it's right here. So watch. Log base 8, close parentheses, divided by log base 2. Now, what should this come out to be? Even if you don't know what we're doing on the calculator. Oops. Didn't push the 2. There we go. What should this come out to be? It should be 2 to the x equals what? 8. 2 to what power equals 8? Right? 3. So it should be 3, shouldn't it? Let's go back to the calculator and see if it is. Okay, cross your fingers. Look at that, 3. Isn't that crazy? On the scientific calculator, you hit 8 first, then you hit log. Okay, so on those little scientific calculators, for the most part, you hit, you hit the function first. I'm sorry, the number first, then the function. On a graphing calculator, you hit the function, then the number. Okay. Well, you divided. It's log 8 divided by log 2. So it's 8 log, actually, on your calculator, divided by 2 log equals, and you should get 3. But don't worry about that on the calculator. That was just in the future. We're going to show you, and there's a rule and everything that we use for that. All right, so don't worry about it right now. All right, everybody good? All right, Justin, you awake yet? Okay, we stopped teaching, now you can wake up. All right, here we go.